we talk about the sewerage system, which is another scope of civil engineers. The sewerage systems plays important roles in sanitation and disease prevention. It deals with the wastewater due to fecal waste, which, if not properly dealt with, can lead to contaminations of environment and drinking waters that can lead to spread of the disease. There are quite a number of sewerage systems. We have the septic tank, sewer network and pump stations, sewerage treatment plants, and etc. Depending the requirements of the local authorities, appropriate sewerage system needs to be designed. Septic tank is a non-centralized sewerage system where each unit of residential or commercial building has a septic tank to collect the sewage, preventing the direct discharge of the sewerage into the drain system. Sewerage treatment plant is a centralized sewerage treatment system which requires the sewerage network directing the sewer to the treatment plant in order to treat the wastewater. There are quite a number of references here. We have guidelines published by the SPAN, Suruhanjaya Perkhidmatan Air Negara. Those are Malaysian Sewerage Industrial Guideline. We have also Sarawak Urban Sewerage System Guideline. Depending on the area of the development, you should follow the relevant guidelines. In these videos, we shall focus our discussions on the septic tank. The relevant guidelines include the guideline for the design and constructions of septic tank in Sarawak and Malaysian Sewerage Industrial Guideline, Volume 5, Septic Tank. Basically, the content and the requirements are similar between the two guidelines. I believe the ultimate references, it will be the Malaysian Sewerage Industrial Guideline. In these videos, I'm going to adopt the guideline for the design and constructions for septic tank in Sarawak. This is the guideline for the individual septic tank with a design capacity not exceeding 30 PEs. PE stands for populations equivalent. It is a quantification measure to determine the working volume of the septic tank for one person. In another word, the use of individual septic tank is limited with the design capacity of 30 PEs per unit building. If it is more than 30, individual septic tank shall not be used. The other system for treatment shall be provided. And it is stated that this guideline for septic tank is to be used for areas where public sewer is not available. Particularly, there is no sewerage treatment plant nearby, then every single unit will have to be equipped with an individual septic tank. Even by providing the septic tank to the building, we will need to also get ready for the future connections to the public sewer when it is available in future. With that, there will be a need of bypass pipe of 150 mm nominal diameter from the last manhole before the septic tank. Now let us look at the effluent standards. This is required by the Environmental Quality Act 1974, Environmental Quality Sewerage Regulations 2009. There are Standard A and Standard B. Standard A's are for the effluents discharged at the upstream of raw water intake points, whereas Standard B is for the effluents discharged at the downstream of the raw water intake points. higher standard shall be required at the upstream, as the intake of the water shall later be treated in the water treatment plant before being supplied to the communities. Now, if the discharge is at the downstream, standard B may be adopted, as this will not influence the raw water intake to the water treatment plant. The design effluent values is given in the table here, which you can get it from the Malaysian Sewerage Industrial Guideline, Volume 5, Septic Tank, in the Appendix B. There are two main categories: effluent discharge to river or stream, and the effluent discharge to the stagnant water bodies. These are the proposed limit for the Standard A and Standard B. The relevant parameters are listed here. 5 days BOD, the biochemical oxygen demand, suspended solid, COD, chemical oxygen demand, ammonia, nitrate, nitrogen, total phosphorus, oil and grease. Now let us look at the design guide as given by the Guideline for Sewerage and Constructions of Septic Tank in Sarawak. We are talking about a retention time of minimum 24 hours, especially when you talk about the cast in situ septic tank. Prefabricated septic tank may also be used. It can be manufactured using the polyethylene, glass fiber reinforced plastic, reinforced precast concrete. These are the design considerations. The design load for raw sewerage should be 250 mg per liters of BOD 5 days per person per day. And the suspended solid, it will be 300 mg per liters per person per day. These are the design considerations. You will need to get ready for future connections of public sewers. There will be a bypass pipe with the internal diameters of 150 mm. Indicates that in futures there are development of the public sewers. This bypass pipe can be put into use instead of having the sewer going into the septic tank. Now the sewer shall bypass the septic tank, entering the sewerage network, which later are to be directed to the sewerage treatment plant. Next, we talk about the volumetric capacity of septic tank. The volumetric sizings of septic tank shall be based on per capita wastewater generation rate of 225 liters per day and a hydraulic retention time of 24 hours. An effective working volume is required for the biological degradations of the wastewater, with an accumulated sludge volume of 2 years, as a typical septic tank is to be dislodged once every 2 years. For septic tank not exceeding 6 PE capacity, the accumulated sludge volume can be based on 4 years interval. This is on top of the requirement that there should be a minimum volumetric capacity of the septic tank not less than 2,000 liters or 2 cubic meters. To make it simple, for the design of the septic tank, you have to determine appropriate size. This is calculated on the basis that 225 liters per day of wastewater is to be generated per capita per day, and the design hydraulic retention time, it will be 24 hours. Let's say now a typical household comprises 5%. That means the PE is equals to 5. By right, the volume of the septic tank shall be 225 liters per day times 5%, which is a total of 1,125 liters per day per household, assuming the wastewater entering the septic tank shall not be discharged within the same day, as you need the retention times of at least 24 hours. Now the question here is, why do we need a minimum of volumetric capacity of 2,000 liters, which you only needs 1,000 plus? Because you need to consider the accumulated sludge. You need times for the biodegradation process before the waters can be discharged as an effluent to the local drains. The biodegradation process is relatively slow. That will lead to continuous accumulations of the sludge over the years. This will lead to the additional capacity of the septic tank keep on reducing over the times, until at the end of the second years, the sludging process is being done. The local council will send personnel to remove the sludge from the septic tank. Now before those people come, you will still need to make sure the retentions of at least 24 hours. That's why the volumetric capacity shall always be more than what is required per household. In the case that the PE capacity is relatively low, the dislodging process can be done every 4 years. Again, you need to make sure the retention times is at least 24 hours. The biodegradation process will reduce the sludge, but not fast enough as compared to the wastewater generated by the household. Over the time, the sludge accumulates. Before it is full, the sludging process should be done in order to ensure the quality of the effluents. And therefore, they set a minimum capacity of 2,000 liters of the septic tank. If you calculated the working volumes more than 2,000 liters, you should use the working volume. If the calculated working volume is less than 2,000 liters, you will use the 2,000 liters. Now the calculations of the working volume shall be on basis of the minimum effective working volume, excluding the filter media's volume as well as the accumulated sludge volume over 2 years. Now if the PE you calculated is less than 6, then the accumulations of the sludge volume should be over 4-year period. The guideline provide working examples to calculate the working volume, which we shall discuss on this in our following videos.